All right, algebra, we are in chapter 2, lesson 6, which we're going to do in two parts. So this is 2.6, part 1. We're just going to go through the first two examples, part 1. And let's warm up our brains by factoring things. We factor everything by factoring by grouping, which we did, a times c is negative 12. Two things that multiply together to get negative 12 and add together to get negative 1. So 3 times 4, and that'd be negative. X squared plus 3x minus 4x minus 12. So factor by grouping. And negative 4x plus 3. So I factor out my common binomial, and I'm left with x minus 4. You can, guys, as you get used to this, you can totally just factor straight to binomials. I know two things that multiply to negative 12 and add to negative 1 would be a minus 4 and a positive 3 and be done. I'm fine with that as you go. When you have an a term like number 2, it's a little bit harder. So I've got negative 6, negative 5. So 1 times 6, let's see, if I have negative, 1 times negative 6 is negative 6, 1 plus negative 6 is negative 5. So when you have an a term, it's a little bit harder. Minus 6x minus 3. Take out an x, I'm left with x plus 1, 2x plus 1. Take out a negative 3, 2x plus 1. So I get 2x plus 1 and x minus 3. I factored it completely. Still warming up. Use synthetic division to divide. So I'm going to divide by x equals 4. I don't know if I have enough room to do this here. All my coefficients. Drop the first one down, so I multiply and add, multiply and add, multiply and add. So I just divided, if I started with a cubed, I've divided by first power, I have second power left. So 2x squared plus 5x plus 2. I don't have a remainder, so I actually don't have to do anything. That's my answer. The volume of a box is modeled by those three factors, where x is in length in meters. What's the volume when length is 3 meters? Volume is modeled by this. X is the length. What is the volume when the length is 3 meters? Well, we have f of 3. So 3 times 3 minus 1, 3 minus 2. 3 minus 1 is 2. 3 minus 2 is 1. My volume is 6 meters cubed. All right, getting into our actual lesson. I'm just going to read. The polynomial function f of x equals 64x cubed plus 152x squared minus 62x minus 105 has negative 5 halves, negative 3/4, and positive 7/8 as its zeros. You have to know what that means. Zeros, solutions, oops, can't spell, solve. Is when we have any polynomial, we factor it into any number of things, and we take each thing and we solve for x. Okay, those are called the zeros, the solutions, solving things. Okay, as our polynomials get bigger, it's harder to find the solutions. Oh, I'm also going to say that it's where your polynomials, oh gosh, that's used, cross the x-axis, right? Those are also the solutions, the zeros, the solve. So when we look at this problem, these are the zeros. There's no way I can do that by factoring. Okay, they're too hard. Notice that the numerators of these zeros are negative 5, negative 3, and 7. are factors of the constant term. I can do 105 and split it into, what, 5 times 21 and 3 times 7. So -5, -3, this can be positive or minus, this can be plus or minus, this can be plus or minus. My constant is a negative, so all of those are true. Sorry. These are all factors of the constant term, -105. Notice also that the denominators, 2, 4, and 8, are factors of the leading coefficient, 64. 2 times 32, 4 times 8. So the numerator is all of the factors of the leading term, the leading coefficient, and the denominator is the leading coefficient, and the numerator is the constant at the end. These observations are generalized by the rational zero theorem, which is right here. So if this huge polynomial has integer coefficients, that's the numbers in front of the letters, then every rational solution 0 has the following form. It's called P over Q. P would be a factor of the constant term, the end, and Q is a factor of the leading coefficient, the beginning. Okay, let's talk about it with a problem. List the possible rational zeros of f using the rational zero theorem. So we're just going to have to take your time and make sure that you've collected everything. So 12 is 1 times 12, 2 times 6, 3 times 4, and once I get back to 4 times 3, I know I'm done. I've got them all. So you remember that is the numerators. The leading coefficient is a 1, so 1 times 1 is the only thing I've got. So I can list factors of the constant. Now these can be positive or negative. So we've got positive and -1, positive and -2, positive and -3. I'm going to erase these now. You can rewind and write them again if you'd like. Positive and -4. Let's see, 2 times 6 and 12. Now factors of the leading coefficient are just positive and -1. So our list of possible zeros is every combination of what you see. I can do all of these, so that's the constant over 1 over, 1. So those are all my possible rational zeros. And of course, to write my answer, I would only write the simplified version. Because when you divide by 1, you certainly don't have to write that. That right there is what we're looking for as far as our answer goes. The list of possible rational zeros. Not too bad, huh? Let's try another one. So first I will list my constant. It's -10. So I have plus or minus 1, and I can go here and go plus or minus 10, plus or minus 2, plus or minus 5, and we're actually done. I left way too much space. And then my leading coefficient is 4, so I've got plus or minus 1, plus or minus 4, and plus or minus 2 in the middle. Now the possible rational zeros is a little harder to maybe list, but I'm going to go ahead and list plus or minus 1, 2, 5, and 10. I'm going to put that over, I don't actually have to do the plus. I'm going to put that over 1. And then I'm going to list the next. This is the constant. I'm going to put that over 2. Yes, we're duplicating these a little bit, but we will simplify later. And then we're going to do it again. I don't know what I was doing there, I'm sorry. I'm mad because I ran out of space. We're going to put that over the same thing, or 4. Now some of these are duplicates, so I can write my final list. I've got 1, and what else gives me 1? That gives me a 1, and that's it. So plus or minus 1, plus or minus 2, that one. I think that's it. I really should be doing these greatest to smallest, but that's okay. Plus or minus 5, that one right there. Cool. Plus or minus 10. Plus or minus 1/2. 1/2 there. 1/2 there. Plus or minus 5/2 there and there. Plus or minus 1/4 and plus or minus 5/4. 1/4, 5/4. So that right there is my final answer. Okay, simplified list of possible zeros. I have 1, 2, 3, 4, 5, 6, 7, 8 times 2, 16 possible zeros because it's positive and negative, right? Cool. Good job. Yep, we're going to practice it just 2 more times. I'm not going to write out everything this time. I'm going to try to simplify my work. Luckily here my leading term is a 1, so that makes it a little bit easier. So I've got just the 15. 1, 3, 5, and 15. Here we have a 2 and a 6. So my numerator, 2 times 3. I'm going to divide that by, nope, I don't have to do that, right? And then again, so my leading coefficient is just 1 times 2, so that's cool. Now let's simplify and just get our answers. Final answer is plus or minus 1, plus or minus 2, plus or minus 3, 1/2, and 3/2. Nice work. All right, so we just practiced finding all the possible zeros for a big polynomial. Now we're going to learn how to verify those zeros. So recall that you have found zeros of a polynomial function when 1 0 was known. We did that back in section 2.5. The rational zero theorem is a starting point for finding zeros when no zeros are known. However, the rational zero theorem lists only possible zeros. In order to find the actual zeros of a polynomial function, you must test values from the list of possible zeros. You can test a value by evaluating f of x using a test value as x. Remember, we learned how to evaluate using synthetic division. And if we got a remainder of 0, it is a solution. If we did not get a remainder of 0, it's not a solution. So let's practice. Find the zeros when the leading coefficient is 1. So first let's list our possible zeros. We have 20, which is 1 times 20, 2 times 10, I ran out of space. 2 times 10, 3 doesn't work, 4 times 5. Those are all our possible zeros. So we're going to test the zeros using synthetic division. So we're going to just pick something. 1 is super easy, so I usually start with 1. I'm going to put 1 in the box and do all of the coefficients, 1, negative 8, 11, and 20. Drop the 1 down, multiply, add, multiply, add, and multiply, add. This is a remainder of 24, so 1 is not a solution. I don't know, let's try negative 1. So put negative 1 in the box, same coefficients. Multiply, add, multiply, add, multiply, add. So negative 1 is a solution, or our factor would be x plus 1. Now if you remember right, once we get it reduced, if I started out with a cubed and I divided by a first power, that means my answer is in second power. X squared minus 9x plus 20. And we can actually factor that second trinomial. It factors to x minus 4, x minus 5. So my zeros are negative 1, 4, and 5. Cool. All right, now we have a practice one. I'm not going to be able to do this on the same page, so hold on, let me hide number 4. So find all the real zeros. My leading coefficient is 1. So all the p's and q's, but we just have the p's here, right? So I've got 1 times 18, 2 times 9, 3 times 6, and I think that's it. So let's try x equals 1. I'm like you guys, I don't want to do this just to go. I'd like to get one that works, but you just have to try. 1, negative 4, negative 15, and 18. Multiply, add, multiply, add. What? Did we really get that lucky? I got a remainder of 0, so I know I'm good. That means I have x minus 1, x squared minus 3x minus 18. This factors into x minus 6, x plus 3. So my zeros are 1, 6, and negative 3. Okay, let's try number 4. All right, first our p's and q's. I have plus or minus 1 and 14, 2, and 7. I'm going to try x equals 1. How can I get lucky twice, right? 1, negative 8, 5, and 14. Okay, multiply, add, multiply, add, multiply, not a remainder of 0. Try again. Multiply, add, multiply, add, multiply, add. That is a 0. So I've got x plus 1, x squared minus 9x plus 14. I can factor that trinomial. let's see, minus 2 minus 7. So I've got x equals negative 1, x equals 2, x equals 7. Cool. That's actually it for today. I tried to take it easy because it's sort of hard. So this will be a lot of practice, and we'll move on to finishing the lesson tomorrow.